It's time now to solve some definite integrals. And when we're dealing with definite integrals, we will generally have a upper bound and a lower bound on your integral sign. And your final answer will no longer be the general antiderivative, but it will actually be a number which represents the area underneath the curve. Now, when you're doing some of these definite integral problems, and for the examples in this video, I'll be focusing on U-substitution, there are different ways to evaluate your definite integral, and I'll be using the method where I'll be changing my upper and lower boundaries so that everything is written in terms of the variable u. And I'll try to explain more of that as I break this problem down. Alright, so for this particular problem, it is a U-substitution question to start. And if I take a look at my terms here, I have, let me just erase my upper and lower bounds now. I have a green term and a yellow term. Well, the green term looks a little bit more difficult to me, so I will write that as my u variable. So that's going to be x squared minus 2x. And if I do that, I can now rewrite my integral being from 1 to 3. And this will now be u to the power of 3 times x minus 1 times dx. And after that, I can take now, on the right-hand side now, I can take my derivative, which is going to be du over dx. And my derivative is going to be 2x minus 2. And then I notice that both terms have a 2 there, so I can go ahead and factor the 2 out. And if I do that correctly, I would get x minus 1. Sorry, x minus 1. And then over here, I would have du over dx. And then from there, I can just rearrange the 2 and the dx. And if I do that, this is a very common step with U-substitution. This would be du over 2 equals to x minus 1 times dx. And the good thing here is this x minus 1 times dx, that lines up with the expression that I have on the left-hand side. So right away, I can make a substitution step. So I'm going to erase this part now, and that's going to be replaced with du over 2. Okay, and then from there I can take this 2 and then I can move that to the front there, so I can write that as 1/2. So erase that, and there you go. So right there's my updated expression for the original problem. Now, I mentioned that the method that I'll be using to solve this problem is a method where I change the upper and lower boundaries. Let me go back to the original problem now. So here's the original problem here in this orange box. When I take a look at the upper and lower boundaries, the 3 and the 1, that works for the original problem because the original problem is written using the variable x's, right? So the 1 and the 3 works well with the original problem because all the variables are written in terms of x. But take a look at the blue box down here. There are no more x's. The variables I have are u. Actually, that's the only variable I have, which is u. So what I need to do now is I need to change the upper and lower boundaries so that is represented in terms of u and not x. Okay, and the way I do that is on the right-hand side, I'm going to replace all of this. So I'm going to erase all that. And let me just rewrite the boundary over here on the right-hand side. So my boundary right now is going to be 1 and 3. Let's go ahead and take this lower boundary, which is 1. This is saying that if x equals to 1, then what does u equal to? Well, I know that u equals to this, right? So this 1 will just represent all the x's. So u would now equal to 1 squared minus 2 times 1. Which means u will now be 1 minus 2, which equals to negative 1. Okay, so what I'm going to do now is I'm going to replace this negative 1 with my new lower boundary now. So my lower boundary was 1 before, but if I write this in terms of u now, my new boundary will be negative 1. And now that negative 1 is written in terms of u, so that matches up with all the variables. Okay, let me just erase that. And let me go on to the upper boundary, which is 3 now. So let me just get my pen out here, if x equals to 3, that means all the x's will now change with 3. This implies that u would equal to 3 squared minus 2 times 3. and that would be u equals to 9 minus 6, and u would equal to 3. Okay, so we kind of lucked out there because my new upper boundary, so my new upper bound actually ends up being exactly the same number as what it was in the original problem, so I don't need to change my upper bound. Okay, so let's go ahead and evaluate my antiderivative now. So if I take a look at u to the power of 3, the antiderivative of that is u to the power of 4 divided by 4, bracket, bracket, and then I have a negative 1 here and a 3. And the 1/2 can just remain on the side there. Okay, and now we can use the fundamental theorem of calculus where the upper bound goes into the variable first. So if I go ahead and evaluate that, the 1/2 would remain, orange bracket, and now I have 3 to the power of 4 divided by 4. And then remember, the fundamental theorem of calculus states that you are actually subtracting the upper bound from the lower bound, so I need a minus sign here. And then let's go ahead and insert the negative 1 into the variable. And now that would give me negative 1 to the power of 4 divided by 4, and then I can close the bracket over here. Alright, so then from there, all we have to do now is just evaluate this, and then we can just finish up, I guess. Okay, so 3 to the power of 4. 3 to the power of 4 is going to be 81. So 81 divided by 4 minus, well, this is going to be just 1, so 1 over 4. And then 1/2 would remain. And then 81 over 4 minus 1 over 4 is 80 over 4. And now this would be 80 divided by 8. So 2 times 4 is 8, and 80 divided by 8 is going to be 10. Alright, so that's how you would, that's your final answer there. And once again, when you're doing a definite integral where you have an upper bound and lower bound, you actually have a number as your final answer and not an antiderivative. Okay, so let's move on to the next one here. Okay, let's go ahead and do this one. I have a numerator and a denominator, and when I look at the numerator and the denominator looks to be a little bit more difficult, so I will let my u variable equal to my denominator, which is going to be x squared minus 2. And if I do that, let me just rewrite my original problem now. I will rewrite that as 1 over u to the power 2 times x times dx. Okay, so all I'm doing here is I'm just taking this part right here, and I'm just taking that red part there, and I'm just trying to rewrite it in a different way so that it's a little bit organized. Okay, from there on, let me just put my upper bound and my lower boundaries numbers for now. I know I'll change those later on, but let's go ahead and now take the derivative on the right hand side. So this will be du over dx, and that's going to be equal to 2x. And then I can take my dx and my, I guess I can take this 2 here, and I can interchange those two pieces. And if I do that, I would get du over 2 equals to x times dx. And once again, that's looking pretty good here because I can take that and replace it with that. And if I do that, I would get 0 to 1, 1 over u squared times du over 2. And then from there, I guess I can take this 2 here and move it to the front. So that would give me the 1/2. And that's looking pretty good so far. And once again, just like the previous problem, the next step I have to do is I need to change my upper and lower boundaries. So let me go ahead and just erase the work that I have on the right hand side over here. And let's go ahead and just rewrite the original lower and upper boundaries here. Let's start with the lower boundary here. So if x equals to 0, that would mean that u would equal to 0 squared minus 2, and then u would equal to negative 2. Okay, so now my new boundary would be negative 2, and this would be 1 over u squared du. Okay, and then after that, let's go ahead and evaluate the upper bound, which is 1. So let me just erase all this now. So if x equals to 1, that means 1 would go over there. That means u would equal to 1 squared minus 2, and that would mean that u would equal to minus 1. So now this minus 1 would go over there. Okay, so from there, I think we have written the expression here in a way where we can now evaluate this. One more thing I would do here is I would take this middle term here, and I would write that as u to the power of minus 2. So let's go ahead and erase this now, and write that as u to the power of minus 2. Now this right here is a little bit easier to evaluate. Let's go ahead and find the antiderivative now. That's going to be u to the power of negative 1 divided by the new power, which is negative 1. Remember, we're just adding 1 to the exponent, and then I can box this, box that, and I did forget to transfer the 1/2 over here, so the 1/2 would be there, and the 1/2 would be over there, and then my upper bound is negative 1, and my lower bound is negative 2. Now, one thing that I'm going to do next, which I didn't do in my previous problem, was you can actually take the denominator and multiply it with your coefficient, and that would give you negative 1/2. And then your inside would be, well, u to the power of negative 1 is just 1 over u. And then this might be a little bit easier to calculate your final answer. So if I go ahead and do this now, this would be negative 1/2. And then the upper bound would go in first. So this will be 1 over negative 1 minus 1 over negative 2. And this calculation here isn't too bad in my opinion. It would be negative 1/2 times negative 1 plus 1/2. And now this would be negative 1 over 2 times, well, negative 1 plus 1/2 is going to be negative 1/2. And then if you multiply those together, you should get 1 over 4 as your final answer there. Okay, let's keep on moving along here. A lot of these questions do take quite a bit of time here. So for this question here, I will take a look at my ln x right there, and I will let u be equal to ln x. Alright, so let me go ahead and update my original problem now. This will be 1 over e, and then e on the upper and lower bounds. And then I'll have u to the power 3. And then this part right here, this x divided by, the x on the denominator and the dx, I will write that as 1 over x times dx. Okay, and then on the right hand side, let's go ahead and find my derivative now. Du over dx is going to be 1 over x. And then I can take my dx term right here and move it to the right hand side. And that will give me du equals to 1 over x times dx. And once again, that's looking pretty good here because this can replace that. And let me just erase this now, and that will become du. Okay, just like all the other problems now, just like the previous two problems, I do need to change the upper and lower boundaries. And let me just kind of clear some space over here. And my upper and lower boundaries are currently 1 over e and e. And let's just start with the lower boundary here. So if x equals to 1 over e, let's just plug that in over there. Sorry, the pen's not picking up here. Okay, if I do that, then u would equal to ln of 1 over e. Now, in order to simplify this, if you're dividing and if you're using your logarithmic rules here, this is the same thing as subtracting them. So this would be ln 1 minus ln e. And I know ln 1 is 0, and I know ln e is 1. So 0 minus 1 is going to be negative 1. Okay, so my new lower boundary is going to be negative 1. Okay, so let me just erase all that. Now let's take a look at my upper boundary here, which is e. So if x equals to e, that means u would equal to ln e, and ln e equals to 1. So this would be my new upper bound. Okay, so let me just erase that now, and then let me just kind of go ahead and copy all of this now. This will be u to the power 3 times du. And now I can find my antiderivative here. What is my antiderivative of that? Well, that's going to be u to the power of 4 divided by 4. And my lower boundary is going to be -1, and my upper boundary is going to be +1. And this is why I like this method a little bit better, because your final calculation steps are going to be a little bit easier to evaluate. If I plug in the 1 in right away, I would get 1 to the power of 4 divided by 4 minus, and then my lower boundary would go in there now. So that's going to be -1 to the power of 4 divided by 4. So this will be 1 over 4 minus 1 over 4, and that just gives me a final answer of 0. Alright, so that wasn't too bad. That was a bit faster than the previous questions, and hopefully as we do a few more, the questions will become a little bit easier. Alright, so for the next problem here, I will highlight my exponent here, which is 2t squared. So I will let u equal to 2t squared. And if I do that, let's go ahead and update my original problem now. This will be -3t. Actually, what I'm going to do first is I'm going to take this expression right here and I'll move that to the front. So that's going to be e to the power of u. And then finally this part right here, the -3t and the dt, I'm just going to park that at the very end. So that's going to be -3t times dt. And I'm just going to park that at the very end because when I do my substitution step, it'll be very easy to replace it. Okay, let's keep on going here. Let's go ahead and find my derivative here. And my derivative is going to be, sorry, it's not dx, it's actually dt. My derivative with respect to t, which is going to be 4t. Okay, and I guess I have to do a little bit more work with my original problem here. So this -3 right here, let's go ahead and just move that to the front there. So that's going to be -3. And let's just take the t and the dt, move that to the side now. And after that, let's go ahead and just interchange the dt and the 4 on the right hand side. So this is going to be du equals to t times dt. And then this 4 would just go on the bottom, so this would be du over 4. And now I can see that this part right here and that part there, that part matches up now. And so I can replace the t times dt with d over 4, or du over 4. Sorry, I think with the change in variable there, I'm kind of saying the wrong things at times, just because I'm so used to the variables being written as x. Okay, and then from there, let's just take this 4 here, and let's move that to the front. So this is going to be now -3 over 4, integral from 0 to 1, e to the u du. Okay, and then after that, I need to change my upper and lower boundaries. So once again, let's clear some space over here. Let me just write another integral sign to start off. It was 0 and 1, and let me just start off with the lower boundary first. If x equals to 0, that means 0, actually, sorry. Once again, it's if t equals to 0, so that would go over there. And that means u would equal to 2 times 0 squared, which equals to 0. So if I rewrite my new boundary here, this 0 would just go down there now. It's going to be 0. And then let's go ahead and take a look at the upper boundary now, which is 1. So if t equals to 1, then u would equal to 2. So then 2 would just go over there now. Okay, and then after we do that, let's go ahead and write the coefficient, which is -3 over 4. And then after that, let's write e to the u times du. Alright, so I have taken my integral, and I have finally rewritten in a way where I can find the antiderivative. The antiderivative of e to the u is going to be e to the u, and then square brackets, lower bound, upper bound, and -3 over 4 in the front. And then let's go ahead and evaluate this. The 2 would go in for the variable u, so this will be e to the power 2 minus, and then the lower bound, e to the power 0. And then the -3 over 4 would come out in front. And then pretty much I think this is it. You don't need to simplify this any further than this. This will be e to the power 2 minus 1, And that right there is an acceptable final answer for that problem. Okay, that's it for that. Let's go on to the last two questions here. So we're almost done. Okay, for this particular problem, I will go ahead and let the u variable be equal to that power. So u would equal to 1 over x. Okay, and then let's go ahead and rewrite the original problem now. This is going to be 1/2 on the bottom, a 1 on the top, and then I have e to the power of u. And then this part right here in orange, let me just write that on the side as 1 over x squared times dx. Alright, so that's how I can rewrite the original problem like that. And let's go to the right hand side now, and now let's go ahead and find the derivative. So this will be du over dx. Now remember, 1 over x is the same thing as x to the power minus 1. And if I take its derivative, it's going to be negative 1 x to the power negative 2. And if I rewrite that, that's going to be negative 1 over x squared. So my derivative is going to be equal to negative 1 over x squared. Okay, and from there on, I can take my dx and this minus sign, and let's go ahead and interchange those two pieces. So that will be negative du equals to 1 over x squared, and the dx would just go over there, and I will multiply with the dx there. Okay, and from here on, I can see that this part right here and this part right here, they match up correctly, so I can just do a substitution step now. So let me erase this, and I'll replace this with negative du. And then I can take my negative sign and move it to the front. So this will be the integral of 1/2, 1, negative, and then e to the power of u times du. Okay, so we're almost done cleaning that up now, and from there on, I need to change my upper and lower boundaries now. So let's do that on the right hand side. Let me erase this now. So currently, my upper and lower bounds are going to be 1/2 and 1. So let's go ahead and start with the lower boundary here. So if x equals to 1/2, then u would equal to 1 divided by 1/2, and that would mean u would equal to 2. So on my integral sign, my lower boundary is going to be 2. Okay, let me erase all that. And then let's go ahead and take a look at the upper boundary here. So if x equals to 1, then u would equal to 1 over 1, which equals to 1. So that would be my upper boundary. So my upper boundary didn't change in that for that particular example there. And let's go ahead and write out the rest of the problem. This is going to be the minus sign here, e to the u times du. Okay, let's go ahead and find the antiderivative of this guy right there. And the antiderivative of that is going to be e to the u, square brackets, 2 and a 1, and the minus sign will go up there. And then let's go ahead and use the upper boundary first. That's going to be e to the 1 minus, then the lower boundary, which will be e to the 2. Close bracket, minus sign there. And I think that's it. This will be your, yeah, that's it. This is your final answer right there in the purple box there. I don't need to simplify that any further. Okay, we're now on to the final question for this video homework guide. Another definite integral where I have to use a u-substitution, and right away I know my u value here is going to be sine x. So u equals to sine x. And if I rewrite my new integral, this will be pi over 3 and pi. And this will be u to the power 3 times cos x times dx. Let's go ahead and find my derivative now. The derivative of sine x is going to be cos x. And then I can take my dx and move that to the top there. And now du equals to cos x times dx. And I think most people can see now that that matches up with that. So let's go ahead and do a substitution step here. That's going to be du. And all we need to do now is I need to change my upper and lower boundaries. So let's do that on the right hand side here. Let's just create another upper and lower boundary here of pi and pi over 3. I always like to start with the lower boundary here. So if x equals to pi over 3, then u would equal to sine of pi over 3. Now sine of pi over 3, that's one of the special angles there, so that's going to equal to root 3 over 2. So if I go ahead and make my new lower boundary, this will be root 3 over 2. Okay, and then let's erase this. And let's go ahead and go for my upper boundary now. So if x equals to pi, then u would equal to sine of pi. And sine of pi, if you think about the graph, pi is right there, so that means u would equal to 0. So that is my new upper boundary. Okay, we're making pretty good progress here, and remember the inside term was u to the power 3, so u to the power 3 times du. This right here is my updated integral there, and now I can find the antiderivative, u to the power of 4 divided by 4, close bracket, root 3 over 2, and 0. And using the fundamental theorem calculus, we use the upper bound first, so that's going to be 0 to the power of 4 divided by 4 minus, and then we use our lower boundary, and that's going to be root 3 over 2, all to the power of 4 divided by 4. And we do need to spend a little bit of time calculating this. This is going to be a 0. And I guess this 4 on the bottom, I can move that to the front as being 1 over 4. And if I go ahead and evaluate that, which I won't, this is going to be root 3 over 2 to the power of 4. And if you do a little bit of work on that, you should get negative 9 over 64 as a final answer there. So definitely take a little bit of time to break down that last calculation, but hopefully the concept of evaluating definite integrals using U-substitution, hopefully you're a little bit more familiar with the technique after watching a few of the examples. I think my first 2 examples were kind of slow, but I was able to pick it up a little bit more at the very end. So just take a little bit of time to practice those questions when you have time.